So in the real world of Web3, yield farming powers liquidity pools, DAO treasuries, DeFi incentives, GameFi reward systems, launchpads and token distributions and all of that. It's everywhere. From Uniswap to sushi swap. I am Sneha from the Web3 Compass, and this is day 27 of 30 days of building with Solidity. I know we're coming to an end of the campaign, but trust us, this is not the end. This is not where we are, putting things on hold. We are going to come up with something even more interesting. We have a lot of community people with us now, and I really, really hope that everyone who has joined us since the start, or maybe somewhere in between, maybe towards the end, whosoever, you have been able to see a good amount of progress in yourself and in your learning. Because we personally, as a team, have learned a lot. We have had some amazing people join us in between. We have got some great feedbacks. We've got some really honest feedbacks too, which we're trying to improve on, and a lot of other things. So I really, really hope that all of this effort was worth it. So let's get started. Everyone who is not aware about what is it that I'm talking about, you can go watch my day 1 video. That is where I talk about the entire campaign in detail. Or you can head over to web3compass.xyz. We have some amazing courses. We have a play section where you can play games, attempt a challenge around Solidity. There's explore section where you can explore communities and all of that. Let us know what are the fun things that you would want to see on the website. And this is the challenge page. We're so close. So day 27, we are going to write YieldFarming.sol. Again, I think we've been covering up and slowly and steadily building the blocks of DeFi while we have started with a real world applications section. And today we're building one of those engines of DeFi, which is a yield farming platform. So we're going to build a system for earning rewards by staking tokens. You will learn how to distribute rewards, demonstrating yield farming. It's like a digital savings account with interest, showing how to create basically yield farming platforms. Again, these real world applications make a lot more sense if you have like a front end and a proper working application in place, but we do not have enough bandwidth to even go with the front end, and I honestly suck at making front ends. So that is why just smart contracts here. So that is what we are going to cover. So, but first, let's talk about what is yield farming. Let's try to make it super simple. Now, imagine your tokens are like seeds. You could just leave them sitting in your wallet doing nothing, or you could plant them somewhere, lock them up for a while, or grow more tokens as a reward. That's yield farming. So you have some tokens, you stake tokens, you let time pass, and then you harvest rewards. Instead of your assets gathering dust, they're gathering yield. And the longer or bigger you stake, the more you earn. So in the real world of Web3, yield farming powers liquidity pools, DAO treasuries, DeFi incentives, GameFi reward systems, launchpads and token distributions and all of that. It's everywhere. From Uniswap to sushi swap. Yeah. From Uniswap to SushiSwap to Curve, behind every reward pool, there's a smart contract that's just like the one you're about to build. So what we're going to build today basically is you are going to create a contract that lets users stake ERC20 tokens, accrue rewards over time, claim their rewards, emergency withdraw, admins can refill the reward pool to keep the farming alive, and we will do it all. reentrancy protection, because now we know what reentrancy attacks are, handling different tokens and decimals cleanly. In short, you're not just handling out tokens randomly, you're building a very fair, secure, time-weighted reward system that keeps the DeFi ecosystem running. Okay. So as a bigger picture of what the logic should be for yield farming contract is, we'll have staking, which basically we're going to write a stake function where users call that function and deposit their tokens into the farm. We track how much they staked, when they staked it. The rewards start accumulating automatically over time based on the amount staked. Earning rewards are calculated second by second, not block by block. The more tokens you stake and the longer you leave them, the bigger your reward. We don't mint rewards magically. They must be pre-funded by the admin into the contract, like refill rewards or whatsoever. Then we'll also write a claim rewards function. So when the user wants to harvest their rewards, they can call claim rewards. They receive at their accumulated rewards in the reward token, and their reward counter resets to 0 after claiming, basically. Unstaking function, again, users can also unstake some of their tokens. So we will write a function there. When they do, they still claim the pending rewards before their stake is reduced. It's a very smooth exit without losing their earned rewards already. And then there would be an emergency withdraw section. So the owner, the one who deployed the contract, can, for emergency withdraw, I think if something crazy happens, user panic, UI, bug, hack, scare, whatever, or they just want to party on the weekends, users can call emergency withdraw. This lets them instantly pull out their stake, but they lose any pending rewards as a trade-off for the emergency exit. Now, we'll have some safety built in around reentrancy guards. Safecast is something new we'll be talking about. So it is used to prevent overflow or underflows when doing math. And then we'll also have some admin controls like ownership and stuff where the person who has deployed the contract can call refill rewards. This adds more reward tokens into the system, keeping the whole thing up and running. Okay. So we will have two contracts. One is the main yield farming contract, but the other contract is not something that we're going to write. Instead, we're going to use it from one of our previous lessons, which is an ERC20 token. Now, we did two variations of ERC20. One was writing ERC20 from scratch and putting all the function, transfer, burn, all of that. And one was where we were using the Open Zeppelin's library, importing it and just writing it in like 5 lines. So that is the contract that we will be using here, or using to deploy our tokens. And yeah, so let's just get started. Okay, so I have lost all my 30 days of Solidity folder. That is why this looks so empty. I'm so sorry. Feel sorry for myself. But this is one file that I've kept saved. This is the contract that we're going to use. You can name this contract anything. I have kept it as token A, TKA. I think we used this code when we were building automated market makers because we had a pool reserve of token A and token B. So that is why we are using this. And now we'll quickly create new file where we say yield farming dot. Okay, so we will just copy this very, very quickly. I hope it's zoomed in enough. Yeah, I think so. Okay, so now there are certain imports that we have to do. One would obviously be ERC20, one would be the reentrancy guard, and the other would be the safecast thing that I said, which prevents basically overflow, underflow of during math operations. So yeah, for safecast if needed, I had just copied it because we're not going to type it, come on. And then we say contract yield farming. Okay, now this is where we get started. Okay, so now the first import gives you the access to ERC20 interface, so you can basically the standard set of functions that you have, transfer from, approve, balance of, all of it will work because users will be staking and claiming ERC20 tokens, and we need to interact with those tokens safely without hard coding anything. Re-entrancy guard, again, this one is super important for security. We have done a detailed video on re-entrancy, which is like, I think, day 20 or so, which is with the title Fort Knox Re-entrancy Guard. So then you can just go watch that if you don't know what re-entrancy is. So we can, once we import this, functions like stake, unstake, claim, rewards, all of these that we're going to write, since these are all handling token transfers, which means that they are potential targets for re-entrancy. So we will use this re-entrancy guard to make sure that once a function starts executing, it locks itself until it finishes. So no sneaky re-entry is allowed, right? And then there will be safecast. Now, I know that this is fairly very new. So in Solidity, when you move between different types of numbers like uint 256 to uint 8, you need to be really careful. If you blindly downcast these numbers without checking, you can overflow or truncate values without realizing it, which can lead to bugs or even security holes. And that is why we need it here. So when dealing with rewards, calculations, especially involving token decimals, we want to make sure we are casting numbers very, very safely. So safecast helps prevent accidental overflows or data loss when we're doing math across different sizes of numbers. Okay. Now what we're doing is we'll create like a custom interface for ERC20 metadata here. Okay. Again, handling a few things. So we will just second. I think I've just copied that entire thing. We don't need to like write it from our end. Just where is the copied folder? Oh, God. Yeah. Okay, so we have to do it before. We have done similar structure before here, that we'll use our interface. And now we're just creating a tiny extension of the standard IERC20 interface. Normally, an ERC20 token guarantees that it will have balance of, transfer, approve, and any other functions. But guess what? Decimals, names, and symbols are optional in the original ERC20 standard. They became common very later on, but not every ERC20 token is required to implement them officially. That's why OpenZeppelin separated it into a different interface called IERC20 metadata. We're creating it here in a very lightweight format, so we can use those functions if the token supports them without assuming that they exist by default. Okay. Also, this will be a re-entrancy. Okay. Now, why do we need this again is our yield farming contract wants to know the decimals of the staking tokens, because when we calculate rewards, we need to scale numbers correctly. So USDC has 6 decimals. Okay. So, and then ETH has 18 decimals. If you ignore decimals, your math will be completely wrong. Users might earn way too much or way too little awards, right? Because what one token would look like for 1 USDC is 1 with 60 units. But for ETH, it will be 1 ETH is equals to 1 with 18 0 per units, right? So that is why we have to look into these sections very carefully. Now, decimals, returns how many decimal places the token use. A name is returns the human readable token name, and symbol is like a short ticker symbol, right? And this tiny interface also matters because your whole yield farming thing could break when taking tokens with weird decimal. So good contracts think about the real world mess that we can create. And since this entire section is called real world applications for us, it is very important for us to consider these scenarios. And yeah, so we've written contract yield farming is the re-entrancy guard. Now we're creating a new smart contract. The re-entrancy guard part is something that I've already talked about. We are just protecting or making sure that we protect the contract from any kind of re-entrancy attacks. And since we're dealing with real money, now once we're thinking of, what are the state variables, what type of data will the farm handle, that is where our work starts. Okay. So, you can just hope that the numbers are like going to work out. Okay. You need to know what tokens are users taking, know what tokens will they rewarded with, know how fast rewards are given out, keep track of who is in charge of maintaining the farm, handle different token decimals cleanly because not all tokens are created equally. So that is why we'll put in some state variables here. So we're saying, okay, using safe cast for UNT 256. Now, this line is a solidity trick. It extends the native UNT 256 type with new safe functions from the safecast library. In plain English, it allows us to call methods like dot to uint8, dot to uint128, etc. directly on uint256 numbers and safely convert between different types without risking overflow or weird bugs. Example, if we later have a uint256 and we need it to safely shrink it to uint8, instead of writing a big check manually, we could just do uint small number, big number dot to uint8, right? That is what makes sense here. Now, what else did we talk about? Okay, which are the kind of staking tokens that are going to be, what the reward token would be in, and all of that. Okay, so then I'm saying, okay, let's write it like this: IRC20 public staking. Okay. Similarly, IRC20 public reward token. Okay. So then this is the token. So staking token is a token that users will stake or lock into the contract. Could be anything, custom token, governance token, StableCoin, whatever. It is stored as an IRC20 interface. So we can call functions like transfer from, balance of, etc. Reward token is the token that users will earn as rewards. Okay, it could be the same as staking token or it could be a different one, whatever. Okay, this gives very flexible kind of scenario to the system that you can reward users with any RC20 token that you want. Okay, now there would be a UINT 256 public reward rate per second. Again, this is more like how fast rewards are generated. It's the number of rewards tokens distributed per second. So if you set a reward rate per second is 1E18, the system is giving out one reward token in a way every second. So this allows you to sort of fine tune the pace of the farming program. Now, obviously, there would be address public owner, whosoever is managing the yield farming. And then there would be staking decimals that we're looking at. So we're saying public staking token decimals. Again, when we do reward calculations, we have to scale math very correctly. So some tokens have 18 decimals, some have 6. So by reading and saving the staking token decimals when the contract is deployed, we make sure that the reward math stays consistent, accurate, no matter what tokens users are staking. No decimal mismatch should happen. Okay, now it's time that we track each user through struct and mapping. There are a lot of things that will, happen. So we'll create a struct. So we're saying struct. Now there's stake or info. Obviously, multiple people are staking it and we need some information. What are those information? UINT256, staked amount. Obviously, very simple. How much has the person staked? UINT256. Reward debt. Now, this keeps track of how much reward the user has already earned but not yet claimed. Okay, that is reward debt. UINT 256 last update. Okay, like when was the entire thing updated last. Okay, like because the reward mapping is, oh sorry, the reward generation is happening. What is wrong with me? Per second, right? So when was the last that it was updated, and since then how much has it claimed? Okay, and then what we're doing is we're doing a mapping for each address with the staker info, so that you can read all of this information. So this is clear. Okay, stake amount, how much amount, reward debt, how much have they earned but not claimed, last update is last time we updated the user's reward. Okay, now it's time that we write events. Okay, I can think of a few. We say event staked, common, very common. We say address, index, user, and UNT 256 amount. Great. Now, a similar kind would be unstaked if somebody has unstaked it. A similar kind would be reward claimed, right? How much amount have they claimed? Then maybe emergency withdraw. We talked about it. Then a reward refund probably, but here will be a change. Here it will be owner, and this will be a reward refilled. Great. Now this was staked, so let's make this unstaked. Great, very smart. A reward claimed, nothing changes. We would need the address, we would need the like user and the amount, right? And then staked would be, this one would be emergency withdraw. Okay, so I can think of these events. You can just feel free to add if there's anything else that you think should be added. Okay, now we will also quickly write, although we will write the constructor, but I think just writing the modifier is also good because we can just do it quickly. So we say only owner. Okay, and we say require owner equals to message dot sender. If yes, great. Only owner can call this. And then we just go about creating this. Okay. Oh my god. Yeah. Okay. So now that we have checked message or sender, owner, not the owner, blah, 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 it's time we write the constructor. It's also become my favorite thing now. So, okay, what do we do in constructor? We have to keep a few things constant. Address of the staking token, because we're going to deploy the ERC20 outside. Address of the reward token. Now, it could be anything. You can be rewarded in the same token that you have staked, that you're staking or deployed, or it could be something else, right? And then there would be UNT 256. Let's talk about a reward rate per second. Okay, very simple. Nothing, no extreme logic we're talking about. Okay, great. Now what? So we're saying the staking token that we have declared is going to be an IRC20, and this. Great. Then reward token. Let me just. Yeah. Reward token is IRC20. Yes. Now what? Reward rate per second. One. That decided. Now we have done it so many times. Yep. Okay. And owner is equals to message. Great. Right. Now we also have to try one more thing, which is try to fetch the decimals here. So we'll write a new thing. We'll say try IRC20 metadata. And what? So we will take the staking token, okay, and then we will do dot decimals. not in caps, decimals, okay? And we say returns uint 8 decimals, great. And we say staking token decimals is equals to decimals, great. Now, this is like a try-catch thing that we are writing here. And then we say catch what by its memory and do what? We say otherwise, we say staking token decimals is equals to 18 because this is by default. If it fails, default to 18 if it fails to fetch. Great. Now, how many of these do we have? Fine. Constructor closes here. Okay, fine. So, till the starting part, I think everything was clear because we're doing something very obvious. We've done this like 1,000 times. But when we talk about the try catch block, so what we do is we attempt to read the decimals function from the staking token. Some tokens, especially non-standard ones, might not implement this, so we wrap it in a try catch. If fetching decimal succeeds, great, we store it. If it fails, we assume 18 decimals, which is the standard for most of the modern ERC20s, and this ensures our reward calculations stay accurate, and all of that. Now it's time we start writing the function. Okay. Function stake. Ha, spelling wrong. Let's go. Uint 256 amount, not mount, amount. Okay, and we are making this external and we are also making it non-reentrant because again, we're dealing with money here. We cannot do multiple calls. So we say required amount is greater than 0. Great. Cannot stake 0. Fine. Good condition to check here. Then what we do is we say update rewards message dot sender. Okay. And then we say staking token, okay, dot transfer from what? Message dot sender, like we're transferring from message dot sender to address this, okay, and then how much amount. Again, for everyone who doesn't know how did I write this, go look at our ERC20 contract. That is where we talk about transfer from function in detail. Like there's a lot of detail around it, how there's an internal function implemented before this and how is it different from transfer in general. So we do this, then we say stakers, it's time we update it. So we say message.sender dot staked amount is plus equals to amount, and then we say emit staked message dot sender. Great. Now, what did we do here? The validation part is obviously shared. Now, is there like a pending reward section? Before accepting a new deposit, we calculate and store any pending rewards the user has already earned so far. This ensures a very fair reward tracking. The new deposit doesn't wipe out or mess up previous rewards. If there are no previous rewards, then it will be 0 by default, right? Now you pull in the staked tokens. So we pull the staking tokens from the user's wallet into the contract. The users must have approved the farm contract to spend their tokens beforehand. Again, a very standard ERC20 behavior. When we show you the deployment, you will have to go to that token a.sol that I showed you and then use the approve there with the deployed yield farming contracts address. so that this thing can work. And then after this line, the user's tokens are like officially locked into the farm. So we increase the user's total staked amount by the newly deposited amount. If it was 0, then yeah, plus add it, right? And then you just emit the staking event. So who staked, how much did they stake? That's it. Now that we have written staked, we will write unstaked. Function unstaked. Again, UNT 256 amount. External again, non-reentrant. Okay. Now, again, this line remains the same. I don't want to write it. Then we check another condition. We say stakers message.sender.reward amount actually staked. AI is just messing up. So the message.sender's staked amount has to be greater than equals to the amount that it is trying to unstake. That is the condition that we're checking here. Then we also look at update rewards, like if they have any pending rewards, because we don't want them to lose out on rewards. So only if you are doing an emergency exit, you have to pay off. So update rewards, message.sender, again, this part is, this will be first. Okay. So we're saying minus equals to amount. So stakers message.sender.staked amount minus equals to amount. And then we say staking token dot transfer. Okay. Because we don't want from the user's wallet, we want to transfer from this to that one. So we just say dot transfer and message.sender and amount. Okay. And then you say emit unstaked. Again, who is the user? Message.sender. And who's the amount? Oh, sorry. What is the amount? Yeah. See how cute little functions we are writing here. Very self-understandable. We're putting it external so that anyone can call it. We're putting non-reentrancy so that we can prevent it from reentrancy attacks. Checking basic validation amount. Is the user trying to unstake more amount that it actually has, and all of that. And then just go about updating rewards before unstaking so that they do not lose on any amount, and then destake it, update it in the mapping and the balances, and just emit unstake. Okay. Now there is a function we will write claim rewards. Okay. What happens here? So we just have to claim it. So we say, okay, let's make this external and also non-reentrant. Okay, great. Now we're saying first, update rewards, message.sender, obviously, because we're trying to claim, so we'll claim the latest one. Then we say UN256 reward is equals to what? Stakers message.sender dot reward text. Great. This is how we read it. Then we say require reward has to be greater than 0. Wow, I'm typing really fast. No rewards to claim. Okay, this is a basic validation. Now we say, let's check one more thing. We're saying a reward token dot balance of. Okay. This particular address of the contract that we're talking about has to be greater than equals to a reward. Why? Because you remember we talked about a reward refilling thing. So we have to make sure that it's enough. Otherwise, insufficient reward balance. Okay. Makes sense. Like, if you're giving out some other reward tokens that you're saying, hey, for ETH, maybe I will give DAI tokens as a reward, and you're running out of DAI tokens. So this is important. Then we say, okay, if everything is working fine, we're saying stakers, message.sender the person is claiming it. So we say reward debt is equals to 0. Then we say reward token dot transfer who, message dot sender, transfer how much, reward, great. And then we say emit reward claimed, who is the user, message dot sender, and this is reward. Any problem in the logic? I don't think so. I don't think so. You should have any problem. I know you guys are smart enough, and this is pretty simple. Okay, we're saying update the user spending rewards so that, you know, before you're handling off any rewards, we recalculate everything based on the current time. Fetch the pending reward amount. We read how much the user is currently owed, stored as the reward debt. Validation checks, reward has to be greater than 0. Then also that the balance of the reward token that we're giving out, it has to be enough. So if the reward pool is empty or too low, the transaction will reward. And then reset a user's reward depth. So after sending the rewards, we reset the user's reward depth to 0, because we don't want the reward to be added up. Like imagine I have 100 tokens as reward, I've claimed it and it does not set to 0. So next time I will have 100 more, whatever time duration it takes. So we have to set it to 0 and then we transfer it. So we send the reward tokens to the user's wallet and we just emit a reward claim, right? Now we'll quickly write emergency withdraw. Yeah, no. Emergency withdraw. Okay. What happens here? Again, external, non-reentrant. Now you have to remember, if we were unstaking it, we were not losing our rewards. We will check what is the reward debt, add it, and then let the person unstake. But in case of emergency withdrawal, the user will have to pay a little bit by losing the rewards that were pending. Okay. So we first calculate amount. So we state stakers message dot sender, again what, dot staked amount. Great, fine. Check that whatever the person is trying to withdraw, oh, that will be there, but we have to say nothing staked. Okay, yeah. Now what we do is we can do another check which says amount as greater than 0. Okay, but also maybe, so we're giving the option to do an emergency withdrawal like entirely. Okay, nothing like partially or something. So we say, hey, stakers, again, this is a chance for you to, you know, add those features. Message dot sender dot staked amount. Is it stake amount? Yeah, stake amount. That is why I don't want. Rewrite it somewhere else. It's stake amount. Great. So we say stake amount is equals to 0. Similarly, copy this again. Okay. The reward debt also becomes 0. Reward debt becomes 0, and the last update becomes block.timestamp. Simple. Okay, now what we do is we do a staking token a dot transfer, and we say message dot sender, and again whatever the amount is, and then we say emit emergency withdraw, who's the user, message or sender, what is the amount, same. Okay, yeah, that's pretty much it. Very simple, straightforward. Check for the amount, withdraw it. So we're saying currently staked amount into a temporary wallet, so you have to load it That is what we're doing in the first line. Then we're checking if the amount is greater than 0. Make sure that the user has something actually staked. If there's nothing to withdraw, the function reverts. Reset all user info, 0 out, user stake and reward debt. Update their last update to the current time. This makes sure that even if they return and stake again, they're starting fresh. Again, transfer tokens and then emit emergency withdraw. Okay, now we'll write an only owner function. So we're saying function refill rewards. Okay, UNT 256 amount, external only owner can do this. Okay, you check reward token. Actually, no need to check. You know that it is low, it's running low. I mean, you can add those utility functions to check, but what we will do is we'll say message.sender and then address this, right? And then we say amount. Yep. And then we just say emit rewards filled. Again, who's the owner? Message.sender. So owner only access protected by the only owner modifier. The owner must approve the yield farming contract first to spend their reward tokens. Then this function pulls the specified amount into the farm contract. And these new tokens are now available to pay out to the yield farmers all over like time and just emit it. Okay. Now we will update rewards because we want to keep things simple. So every time a user stakes, unstakes, or claims rewards, we need to recalculate how much they've earned based on how long they've staked, how much they've staked, how fast the rewards are being distributed, and all of that. So we say, let's write another function. Function update rewards. We say address user. And this has to be an internal function. We'll grab the user. Yeah, we'll grab the user's data from the storage. We can update it directly without copying it into the memory. Any changes we'll make will reflect instantly on chain. So we're saying staker info, which is struct storage staker is equals to staker's user. Okay, so we're loading all of that information for this particular user. Now we say, okay, if staker dot stake amount is greater than 0. Okay, what do we want to do? We're saying UNT 256. Let's calculate the time difference. Is block, not clock, block dot timestamp minus staker dot last update. That's how we were calculating it. Then we say UN 256 as a reward multiplier. Okay, so we say 10 to the power staking token decimals. Again, we're dealing with powers here. 10 to the power 18 away is like 1 ETH. And so, and then we will say UNT 256 pending a reward. So we say time difference, okay, into a reward rate per second into staker dot stake amount divided by reward multiplier. Okay, and then we say staker dot reward debt plus equals to pending reward. Now, every time you want to check how much have you earned in the time that has passed, this is the function that you're going to use. And yeah, this is when the stake amount is greater than 0. Otherwise, and then you say staker dot last update is block dot timestamp. Yeah. Now, I know I don't think any of it would be very, very complicated for you now, but yeah, just to go through, we grab the user's staker data from storage so we can update it directly without copying it into memory. We will check if the user has staked any tokens. So only update rewards if the user actually has something staked. If we have nothing staked, there's no need to calculate rewards. Calculate how much time has passed again. Block timestamp minus taker.last update. Set the reward multiplier based on decimals. Since tokens might have different decimals here, we normalize the reward calculation using the token decimals so that fair units are transferred. Okay, so then we calculate the pending reward with time difference, which is the time passed, into the reward rate to the staked amount, and then divide by the reward multiplier to adjust for decimals. This gives us the new rewards, and then we just add the newly calculated rewards to the user's reward debt. The reward debt will later be claimed when they call claim rewards and stuff. Okay. Now, if you want to peek at your earnings literally without touching them, we will write a function called pending rewards. Okay. Address user. Again, this will be external and this will be view because we only want to look at them. We want to know how rich we are. So we say UN256. Staker info memory, load all that data into the memory. We want to peek at it, right? Stakers user. Okay. Now, UN256 pending reward is equals to staker dot reward debt. Okay. And if staker dot stake amount is greater than 0, okay, we're saying again same thing. Wait, let me just copy this entire thing. Okay, what is different here? Actually, nothing. So I will just say a return pending reward. Okay, what just happened here? We load the user's taking information into memory, not store it, since we're just reading the entire thing, not changing anything. So using memory saves gas and is faster. You start with the current stored rewards. So whatever reward the user already has accumulated but not yet claimed, this acts as the base pending reward. If they have staked tokens, add new rewards. That is where all the calculation comes in. Same as what we have done before, and then we just return the pending reward. Great. Now we'll write some cute little utility functions which will help in the front end. We're saying function. Okay, yeah, we've written everything. So we're saying function get staking token decimals. Okay. External view returns uint8 and we say return staking token decimals. Yeah, that's our helper function, one line. So when deployed the contract, we fetch and saved the staking tokens decimals, and this function will simply return that stored value. Okay, now when you have to deploy both of them, what you will do is, let me see if Remix is working now. Okay, so something is extremely wrong with Remix. It has been down for like forever. So here I have a task for you. You will try deploying, both the contracts, the ERC20 and the yield farming, and perform all the functions. For the past 26 videos, we've been showing how to deploy, how to interact, and we had a lot of errors. We fixed it. So see if anything is not working as per your thought process or as per the contract should have worked, and then just fix it. Let us know. Come on our Telegram. Let us know that, hey, there's an error, or hey, I think we should add this. I would like to raise a pull request and all of that. Yeah. So in the text-based solution, you have the entire steps to deploy it as well. All you have to do is deploy two simple ERC20 tokens, one token that user will stake, one token that user will earn as rewards. Okay. And then you have to deploy your yield farming contract. And then in the staking token, you have to add the address of the stake token. In the reward token, you have to add the address of the reward token, and reward rate per second you will adjust. And then just go to your ERC20, call the function approve. Again, if you don't understand why this has to be done, go back to our ERC20 video. That is where we talk about it. So then you go to approve and then add the approval, and then just play around with yield farming. That's pretty much it. Make sure that you do this. Also, thank you for all the support that you've been giving us. Please feel free to share it with anybody who you feel can benefit from these videos or learning Solidity or is interested to learn Solidity. And also make sure that you hop on our Telegram, follow us on social media, Twitter, LinkedIn, and all of that. And yeah, we'll have our community call very soon to talk about what we should come up with next. So if you have any suggestions, you can let us know in the YouTube comments or on our Telegram group. Till then, keep building. I will see you on day 28. Bye, guys.